We're in section 3.3 now, the last section of the chapter. And we have learned how to enter data, compute central tendencies, and found many measuring principles to analyze the data. So now we ended section 3.2 with the bell curve. And we said it was normally distributed. And we said that was a key word. Well, in this last section, we're using the bell curve and adding to it, I shouldn't say but, the concept the conversion of the X bar and standard deviations to no values but the use of a number line where X bar is 0 and then a movement of standard deviations are numbers. So let me write that out for you. Okay, the reason is because we're finding z-scores. What this did, kind of big, but we're going to tell you sometimes. So 0 is always X bar. And then this is 1 standard deviation above the mean. This one's 2 standard deviations above the mean. and this one is 3. So we have a number line going here that helps us locate where the data is. This is a -1, this is a -2, and this is a -3. Of course, we can go to infinity because the line, the bell curve never ends. But we primarily have the majority of our data within those 3 standard deviations. And what we're saying here is that by having this conversion of the bell curve into these units, we can now calculate each position of a data value knowing its bar and standard deviation and the x value. So we'll be doing that. What that is the basics of z-scores, percentiles, quartiles, and box plots. That's what we're looking for. But we're going to start with a z-score. A z-score identifies position of the data of a normally distributed data set in terms of a single digit digit. All right, and we have a formula. This here is what the book said about a z-score. And a z-score is the number of a standard deviation that is given value x is above or below the mean, because again, positive or negative. The z-score is calculated by using this formula. Notice that we have x, which is the data value, minus x bar, which is the mean of the data, divided by the standard deviation. All right, so I've gotten this off of the internet because this shows the general form: 0, 1, 2, 3, -1, -2, -3. And you can understand that the most center place where it's symmetric is the mean. And here is what we've done in multiple exercises, is to find the 2 standard deviations around the mean, values not significant, so we can identify which areas are significant, significantly low or significantly high. So we're going to do some examples of this, and nothing difficult. Primarily, it is easy to go. Here we go. Researchers measure the data speeds of a particular smartphone carrier at 50 airports. So my N is 50. The highest speed was measured at 76 6/10 Mbps. The complete list of 50 data speeds has a mean of 17 and 95 Mbps. Sorry. Better make it smaller and I can write more. And a standard deviation of 17 and 91 hundredths Mbps. Okay. What is the difference between carrier's highest data speed and the mean of all 50 speeds? All right, well, what are they asking? Okay, so we have to figure out the span between, notice between the carrier's highest speed, so between, difference means to subtract, and the mean. So we're going to have the 76 and 6/10 mpbs minus the mean, which was very small, 17 and 95 hundredths mps. So we're going to do the math on that with our handy dandy calculator. And I get 58, 65. So let me see what I've got here. Oh, I put a 95 and it's not a 95. I'm doing a little mistakes here as I'm looking. 1791 and the high was 76.6. 58.69. I'm going to do it again. 76.6 minus, and the 17, oh, it is 95. 58.65. Sorry about that. Yeah, I was right with a 5. It is a 5. So that gave me 58.65. All right. Now, that's the difference. Okay. The difference is how many standard deviations. So we want standard deviations. The answer to the first one is that M. Okay. Now, how many standard deviations? Well, to find how many standard deviations, you take difference divided by standard deviation. Okay, so we got the difference. So for this number right here, we're going to have the 58.65 and divide by the standard deviation of 7. Oh, that's where I got the 1791, because they're so close. That's what happened. I said, God, why are my numbers all crazy? Okay. I work everything out before I teach it just to make sure that I know the general size of the number. So we're going to take our calculator and do the clear and do a 58.65. Everybody do it with me. Divided by 17 and 91. And I get, well, we want a standard deviation of at least 2 points. So it's going to be there's two decimal places, 3 and 27/100 is our standard deviations around the mean. All right, so we have the difference is 3.27 standard deviations. The z-score is, okay, now they want the z-score. So our third one is find z-score. To find our z-score, we're going to be using our value of the highest, which was 76.6. And we're going to subtract the x bar, which is that difference that we just got, 17.95, and divide by the standard deviation, 17.91. So this number right here is the same, because this part right here is that value right there. So the carrier's highest data speed is, and in this case, is it significantly high? Is it not significantly high? So one of the two. Well, let's look at it. The high, we're comparing 3.27, and we want between -2 and 1. So in this case, we're saying 2. We're comparing it to 2. So this is the z-score, and we're comparing it to a 2.00, and this number is greater. Therefore, it is significantly high for that speed. Very good. All right, let's move on. I'm going to, I need some eye drops. My eyeballs are acting up. Okay, we're going to read this one. Use the range rule of thumb to identify the values that are significantly low or high, and the values that are neither significantly low nor high. Okay, so we're going to read what they say, and then we're going to construct this number line to help us clue in using whatever we need, whatever means we need to get this problem solved. So we have, just a minute here, test is used to assess readiness for college. Now, that's what those entrance exams always do, is measure where you stand in your knowledge recall. It doesn't mean you're not college ready. It just means that some things we hold and some things we let go. And we're always studying that to figure out how many classes we do of each kind. So here we go. In a recent year, the mean test score was, so our X bar was 22 1/10, and a standard deviation of 5 and 2. Okay. Identify the test scores that are significantly low or significantly high. All right. So what we're saying here is that we've got the 22 and 1. And we want 2 standard deviations around this. So we're going to do a little bit math. It's just very little. For the low, we would have our 22 1/10 minus 2, 5 2/10. And then for our high, we would have the 22 and 1/10 plus the 2 times 5 and 2. And those will give us the positions of the high and the low. Some little math. I told you this was really good. 11.7, significantly low. Or less. 11.7 or less. And then we want a plus there. And we have 32 and 5/10. So these values, if we had, of course, this is normally distributed, would be right here. And we could see that this is in the negative side and this is in the positive side of movement of those standard deviations. Those are the two answers. All right, let's look at another one. These go fast. I talk too much, I know. In designing a work desk, it is found that males have a sitting knee height with a mean of 21 and 3/10 inches. All right, 21 and 3/10 inches. And a standard deviation of 2 and 2/10 inches based on the data from the Department of Transportation. Use the range rule of thumb to identify the values that are significantly low. All right, and then we want, that's A, and the B is significantly high. Okay, so again, small math because we have what we need. So the low is going to be the 221 and 3/10 minus 2 times the 2.2 tenths. And on the high, it's the same values except a plus. And we're working. So let's get that done here with the math. 21 and 3/10 plus, or I'm going to do the minus, 2 times the 2 and 2/10, and I get 16.9 or less. All right, so I'm going to take my calculator. I'll do a second enter to get an entry. I'll move it like this and make it a plus. Enter, and oops, I did something wrong. Oh, I didn't. Oh, sorry. That's what I'm going to just type it in because I put the plus on the wrong one. I have hay fever this morning. My eyeballs are crusty. And on this one, I get 25 and 7/10. So we can say the same thing we did over here, only say or less, or higher, I should say, which is the upper, or higher are significantly. All right, very good. These are, like I said, the Z-score section that culminates this particular study is pretty calm. So here we are. This is use of z-scores to compare the given values. So now we're calculating z-scores and then comparing them to evaluate some significance of some form, an inference of the material. Based on a sample data, newborn males weigh 3226.2 grams, 3,226 and 2/10 grams, and a standard deviation of 844 and 7/10 grams. Newborn females have the same weight with a mean, have weights with a mean, sorry, not same weights, have weights with a mean of 3,041 and 7/10 gram. A little bit smaller, aren't they? And a standard deviation that's kind of high, isn't it? With a standard deviation of 499 and 5/10 gram. Who has the weight that is more extreme in the group from which they came? A male who weighs 1,700 grams or a female who weighs 1,700 grams. All right. So we have to now find the z-score for 1,700 grams. That's not very big. All right. So let's see what happens if we find the z-scores for these items. So let's get started here. For the female, the z-score is going to be 1,700 minus the mean, which is for the males, 33. 32, sorry about that. My eyeballs are really clouding on me. I might stop in a minute. Minus the 32, 26.2 divided by our standard deviation, which was 844.7. All right. And for the females, it's going to be the 1,700 from the 3041.7 divided by the 449.95.5. All right. So let's do some math. Okay. As we do the female, we're going to start with the parenthesis and do the 1,700 for the data connection. 3226.2 close parenthesis divided by, and we're doing the standard deviation, which was 844 and 7. All right. So I get a z-score of, and that's, I'm going to do 2 decimals. I get one that's a negative 1.8067, blah, blah, blah. So we're going to say negative 1.81. How does that sound? All right. So we got that one. Now we're going to do the next one. And for the males, we're going to start with our parenthesis and put the 1,700 grams, subtract the 3226, and I'm sorry, this is the females, 0.304 1.7, sorry, and I have it written, I just looked up top. And I get a value of a negative 2, uh, 2 point, and I'm going to round, so I'm going to say 6, 9. All right, so now that I have the z-scores, and it says here, since the z-scores for the male is a negative 1.81 and the z-score for females is negative 2.69, we can say the female weights has the weight that is more extreme because it is past negative 2. Now remember, on our scale, if I have 0, I have a 1, 2, and 3. And on the other side, negative 1, negative 2, negative 3. Well, the z-score for the females is 2.69, so it's about right here. And the males is negative 1, here's negative 1, 1.8. So this is the males and this is the females. This is more extreme, the one that's over here close to 3. All right, I'm going to stop right there and I'll continue with percentiles.